Welcome back to first session of Applied Machine Learning in Security and Privacy Applications. Today we will start with some basic concepts of machine learning, so you guys will be better familiarized with the machine learning fundamentals. So let's take an overview of the machine learning algorithms. So we will cover three major categories of machine learning models. First of all, we will go through supervised learning, and then we will cover unsupervised learning, and in the end, we will go through reinforcement learning. So for now, take a look at supervised learning. So what is supervised learning? As you can see, the supervised learning would be a model that is trained on a data set that is manually labeled. So in this case, for example, we have a data set of cats and dogs and other animals, and some humans would manually put a label to each of these images. So as you can see here, the model would produce some outputs, and then it will be compared to the desired output, which is the labels, and continuous training. So supervised learning would be categorized into regression and classification. What is the difference between these? The difference is only the kind of the output, and this is when we're talking about regression, it's like a continuous output. As you can see here, the temperature is a continuous output, but whether the weather is cold or hot is like a discrete output, so it would be a classification. You can see here the regression and classification differences by charts. So if we want to classify the model with the regression, it's like a line that will go through even some samples over here. But in the classification, the line will completely divide the categories. Some of the famous applications of supervised learning would be object detection or machine translation or even spam filtering. So next we have unsupervised learning. So as the title implies, unsupervised learning would be the opposite of supervised learning. So in this case, we have a dataset that have no labeled data. So the model would learn by itself that how many categories we have and what categories we have. So if we want to see the difference, as you can see, if we have a supervised learning, we have defined our categories. In these examples, like 2 categories, and each of our inputs would be mapped to either of these categories. So if, for example, we have a third category input, it would be wrongly mapped to each of these categories. But with the unsupervised learning, the model will learn itself how many categories we have and what are these categories. So it would be like a clustering thing that defines each category as the model detects. If I want to summarize the unsupervised learning applications, it would be like 3 major applications. First of all is simply clustering. which is used in recommender systems, targeted marketing, customer segmentation, or even anomaly detection and threat detection. But the next two application would be something that is not really a machine learning thing, I guess. So if we want to pre-train a machine learning model, we can use unsupervised learning. So in this case, it's like that we want to get a model with better initialized weights or better initialized layers and structures. So we can do it with unsupervised learning, that is called pre-training. And the other application would be dimension reduction. And that would decrease the dimension of our data. So this would be good in big data visualization or structure discovery and other applications. So the next category is reinforcement learning. Reinforcement learning is somehow different. The data in this category would be in forms of actions, observations, and rewards. So let me grab a simple example. For example, the model of reinforcement learning is called agent, is a baby. This baby, based on its environment and the predefined actions, will select an action and do that action, which is here, for example, crawling. And based on this action, the model will receive a reward that is either a negative reward or a positive reward that will kind of feed back to the model that how it should select its next movement and its next action. So as you can see here, we have four main elements in the reinforcement learning. It's the agent itself, that based on its observation and actions and rewards would decide to do which action. And after that, that environment will produce a reward and send the feedback to the agent. So the agent would then decide what to do next. Most use cases in the reinforcement learning is like networking things or in autonomous devices or robotics. So in case of networking, we have some intrusion detections like data offloading, anti-jamming, and interference avoidance. And in case of some IT networks, we have like robotics, navigations like autonomous vehicles, resource allocations, or indoor localizations. And this last category, it would be like the antennas, algorithms, which is so complex, PH layer authentication or canvas authentication. So if we want to see once again what we have covered until now, we have covered the machine learning main algorithm types, which is supervised learning that works with labeled datasets. It can be either classification or regression based on the kind of output. Also, we have unsupervised learning, which is trained by unlabeled datasets. That is called clustering. And we have reinforcement learning, which is like a four elemental thing that is based on actions and rewards and observations that model will decide what to do. Here I provided some famous algorithms of these categories of machine learning. We have, for example, linear regression, logistic regression, random forest, and neural networks for the supervised. And for example, k-means clustering or PCA for the unsupervised. We have a fourth category, which is like semi-supervised. It's like a hybrid approach in between of supervised and unsupervised. And for the reinforcement learning, we have some famous algorithms such as Q-learning, Monte Carlo. I also have provided a better roadmap to machine learning. So based on what you need, you can be lead to special category. So for example, if you want dimensional reduction, you will go to topic modeling or probabilistics. So you will get a correct category here. Or if you do not want dimensional reduction, then if you want to predict something, it's your decision to want speed or accuracy or don't want the speed or accuracy. So you will be mapped to a correct algorithm to choose. So that's it for today. Hope you enjoyed this video. Please tell me in the comments what you think of this video, whether I need to get more details for you guys or that's enough of details and you like me to proceed at a faster speed or anything else. Please let me know if you have any questions and I will answer you in the comments. Please don't forget to like this video and share this video with your friends. And also, please hit the subscribe button and follow us on InfoSecTube channel and wait for the next videos. Bye!